Welcome to the Explainer. Okay, today we are diving headfirst into something that is absolutely taking the engineering world by storm, and that is AI testing agents. There's a massive amount of hype right now, right? People are suggesting that autonomous AI agents are going to just completely replace traditional automated testing. But we really need to ask, what happens when you actually unleash these agents in a real complex engineering pipeline? We're going to break down the pragmatic reality versus the promise today, and we're going to use some incredible hard data straight from the engineering team at Slack to do it. To kick things off, I want to anchor us with a really powerful quote straight from Slack's engineering deep dive. Tests enforce journeys, agents verify goals. Now, this isn't just some catchy marketing phrase. It's literally the fundamental paradigm shift we're about to investigate. See, we're moving from telling a computer exactly how to do something, step by step, to just telling it what we want achieved and letting it figure out the rest. Here is our roadmap for today. We'll look at journeys versus goals, dive into the Slack experiment, unpack the reality of reliability, look at some hidden costs, and finally, build the new testing pyramid. All right, Section 1, Journeys versus Goals. Think about traditional end-to-end tests. They're basically brittle sequences of super rigid steps, right? Click here, click there, type this, assert that. If a developer moves a button by even one pixel, boom, the test breaks. But agent-driven tests? They're an entirely different beast. You give the agent a broad goal, like, hey, send a thread message, and the agent autonomously adapts. It observes the screen, it navigates the UI on its own, and it verifies if the final result was actually achieved. It's a dynamic process rather than a static one. But, and this is a big but, here's where we hit a massive wall of developer skepticism. Can an automated test that costs up to $30 and takes over 10 minutes for a single run actually fit into a modern, high-speed workflow? That is the multi-million-dollar question. And honestly, it's exactly the question that triggered Slack's engineering team to conduct a massive internal investigation in the first place. Which brings us to Section 2, the Slack experiment. To figure this out, Slack ran over 200 automated executions using non-production data, and they tested 3 very distinct execution models. First up, Agent plus Playwright MCP. This uses an explicit protocol to give the agent predefined browser actions and a persistent memory context. Second, they tried Agent plus Playwright CLI, where the agent is literally running shell commands and has to rebuild its state from snapshots every single step. And third, generated Playwright tests, where the AI just acts as a coder. It writes deterministic test code that is then executed normally like any other script. To really find the breaking points of these different infrastructures, they threw 2 different levels of complexity at them. They had a simple flow called thread reply, taking about 15 to 20 steps. Then they stepped it up with a medium complexity flow called search discovery. This one took 25 to 30 steps and required the agent to navigate results and move between entirely different views in the app. Moving into Section 3, the reality of reliability. Okay, get ready for a massive plot twist. When we look at the failure rates for that complex search discovery flow, the agent using the MCP integration failed only about 12% of the time. The CLI agent failed roughly 20%. But those generated tests, they failed a staggering 48% of the time. That's almost half. Even though an AI wrote the code, once that code was locked in, it just couldn't handle the natural, everyday variability of a live UI. It absolutely proves that live app state and the infrastructure you use to connect the agent to the browser matter immensely. Now, before you completely write off generated tests, keep the number 3 in your head. 3 minutes. That was the average runtime for the generated Playwright tests, making them incredibly fast and efficient once they're actually written. The live autonomous agents, on the other hand, they took an agonizing 5 to 11 minutes per run. Why the huge gap? Because the agents are literally thinking and analyzing in real time. So we really need to understand why these live agents are so much slower. And honestly, it all comes down to adaptability. In Slack's experiment, only 20% of the agent runs followed the exact same sequence of actions. Think about that. The agents were dynamically exploring the interface on the fly. They opened menus in totally different orders. They clicked different suggestions, and they discovered entirely alternate navigation flows just to reach the exact same goal. Now, this variability is absolutely incredible for finding weird edge case bugs, but it's terrible if you just want pure speed. Let's pivot to Section 4, the hidden costs. Brace yourselves for some serious sticker shock. $15 to $30. That's the cost for a single execution of an agent-driven test run.
If you're a developer or an engineering manager listening to this, your budgetary skepticism is completely validated right now. Running these live agents on every single code commit is just financially unfeasible for the vast majority of teams.
So, why on earth is it so expensive? Well, it's all about the turns, the back and forth interactions the model has to take. The MCP model took about 40 turns, but look at the CLI execution model. It took over 85 turns. It took more than double the interactions to achieve the exact same result, which naturally leads to a massive token explosion.
Let's actually walk through why this high turn count absolutely wrecks your wallet. It's due to something we can call the system prompt tax cycle. On every single turn, the agent observes the UI, it reasons about the action, it executes it, and then, here's the kicker in step 4. Because the underlying API is stateless, it has to resend the entire conversation history plus the massive new browser accessibility snapshots all the way back to the model.
And that brings us to a super vital realization. The cost is being driven by context growth and turn count, not just the model's reasoning capabilities. You aren't really paying for the AI's brilliant intelligence. You're paying a bloated memory retransmission tax. It's kind of like paying for a taxi where the driver forgets where you're going every single block, and you have to hand them a heavier and heavier map every single time just to remind them. Finally, Section 5, the new testing pyramid. First off, let me reassure everyone out there. Deterministic end-to-end tests, they are absolutely not dead. Whether they're written by a human dev or generated by an AI, these rigid tests remain the undisputed champions for continuous integration. They're lightning fast, they're beautifully repeatable, they enforce specific user journeys, and most importantly, they cost almost nothing to run on repeat all day long. But agentic testing definitely has a very specific, incredibly valuable home. Think of it as a premium exploratory tool. When you have a flaky workflow or a messy, hard-to-reproduce bug out there in production, you don't write a rigid script. You point a goal-oriented agent at it. You let it explore the complex UI behaviors organically to figure out exactly how a real human user might be breaking your app. So this brings us to the final blueprint, the new testing pyramid. We've still got our classic foundational layers, unit tests at the base, integration tests in the middle, and deterministic end-to-end tests right above that. But now we've essentially added a fourth layer. Agentic testing sits at the very peak. These two paradigms, they don't replace one another. They stack together perfectly so you can cover both the predictable paths and the completely unpredictable human behaviors. Which leaves us with one final thought to take away today. As AI tools become more and more integrated into our daily engineering lives, the question really isn't whether you're going to use agents. The real question is, are you going to burn your budget trying to force expensive agents into high-frequency CI pipelines, or will you deploy them strategically like elite detectives to solve your team's absolute most impossible bugs? It's time to evaluate your pipeline and choose your tools wisely. Thanks so much for joining me on this explainer.